This name of this presentation is called Unraveling the Truth. My name is Bill Pagano. I am a professional engineer. I have my bachelor's in civil engineering, and I'm also a professional geologist, and I have my bachelor's and master's in geology. Warning, put on your seatbelt for quite a ride, especially for you geologists. Also, all images and this entire document have been copyright protected. Background, how this all got started. I did a field study in Bear Mountain State Park and vicinity in New York, lower New York State, 2002 to 2007. I was mapping the Precambrian era bedrock. The Precambrian era bedrock is approximately 1 billion years old in that area. Precambrian rock on Earth has been mapped as old as 4.6 billion years old. I took structural data, which is numerical data of orientations of rock and fractures. So the results, not all of it was published, partially because of the timing. Most of my more productive work was towards the after 2004 or whatever, but there was two quadrangles, the Popolopan Lake quadrangle and the Thiels quadrangle, where bedrock was mapped in the structural data map. In the Popolopan Lake quadrangle, only my structural data was published. I didn't get the mapping published, showing the layering and all that. And there's, for the Thiels quadrangle, nothing was, either structural data or mapping was put in that. So some of the results, visual results here. It's a very, very complicated area. There's a lot of brittle faulting. Brittle is like fracturing and things like that, as opposed to ductile, which you'll see a lot of in this presentation. So you can see it's like a jigsaw puzzle. There's a lot of what's called right lateral faults. You can see there's like a structure here, and you can see the same thing kind of duplicated here, move to the right. The arrows indicate the direction of movement. All right. So here's some, you can see a little more clear, the colors are the different kinds of rock. Those little squares are like locations that I visited, which are actually, it's incomplete. There's much more than that. Worked like crazy on it. You can see there's features here. This is structural things that are being rotated counterclockwise. There's a feature here that's like distorted, and you'll see a lot more of that. Here's something over here. Right? You can see some faulting here. You know, why does this stop here? Because it's been faulted. Things have moved. This used to connect to this, for example. Actually, check that. This connected to this. It's a right lateral fault. Move to the right. Here's more of those features that seem to rotate. A lot of times things are in series. There's one of those again that got due to faulting. Actually, these are ductile features. Anything that curves or twists or bends is ductile versus brittle. Like you saw in the first, there's all that brittle faulting. This is really brittle and ductile. Here's a good example of faulting here. This zone of rock matched up with this. It was moved to the right. The more major faults are right lateral, moving to the right on the other side of the fault. Okay, so I saw that a lot of these, the structural data, which is all tied into the mapping and the bedrock type and all that, there is certain segments to it that change as you go through different areas. Like you take, these are lettered, looks like B, C, D here, B, C, D, E, F, and it kind of evolves here, B, C, D, E, F. So you can see this propagation going on. So I started to see that there was a larger scale feature here. And this is what it looked like, the whole area mapped. And it's about 6 miles this way, about 4 or 5 miles this way. We'll go over what these things are later. You can see some, I suspected some feature here. So when I put everything together with those sections, and I followed one layer. Now layers are going to change composition, but if you follow the orientation in one direction, what I'm saying here is following one layer around prior to brittle deformation and loss of sections by faulting. So in other words, you correct everything for this brittle faulting and everything deformed and this and that, and you piece it together to determine what this structure. This is what I got. All right. We'll go over what's going on here later, but you can see there's a counterclockwise rotation again. There's some kind of flow going on. There's a right lateral fault, which I determined from other data. There's information here that I knew there was right lateral, but these major faults, like I said, are right lateral. There's a shearing going on here. The structure gets thin and shears down here. There's some kind of rotation here. Always on one zone, on one side of the fault, there's this counterclockwise rotation. Even in this spot, which I didn't show here, there's a counterclockwise rotation. So the feature gets kind of fatter here because of the flow, and it's compressed here. So everything kind of makes sense. You know, you're compressing it here, it's bulging out here, it's complexly folded in here. And yeah, I started seeing that things looked like what you got going on the East Coast, but I'll talk about that in a bit. East Coast of America. So what's going on is this is called a refold. That's what this structure is. And it forms by the difference in history of stress. History of stress and folding is in perpendicular directions in this case. The resulting form in blue is the most basic form of this type of refold and is the starting point of all variations to this form. Where these forms exist, there are many. You don't just get one. And they only show a few here, but there's a whole huge area where these would happen. These forms have a high degree of stored potential energy and are relatively stable in regards to durability. You can't just tear these up. You know, you can't, anything could break during brittle faulting, for example, but you can't just totally tear these up in early stages of deformation. Any potential breaking of the chain of refold structures, call this a chain, it'll first occur outside and between any refold structures, because like I said, these are relatively resistant. They're durable, so you're not just going to break them. So just remember that concept, that if you're going to break these, it's going to go outside of the refold structures. So again, here you have compression going this way to make these folds, and then you have compression in the exact opposite way, 90 degrees from it. So it shows the folding due to that pressure this way. So you put the two together and you get like this refold. And you can see things like that in real life, like on a bedspread or a shirt or whatever, where you can't seem to get these wrinkles or dimples out of the material. They just want to go into these annoying forms or whatever. So these refolds, they come in different, there's a reason they change shape. Your basic textbook form, which I showed, is that crescent moon, but the forms change from initial basic form to many variations dependent on the following: locations of faults. Got the faults shown here. This is like ductile faulting. Faulting starts out ductile when it's deep and under high pressure, temperature and pressure. So it depends on the direction of flow related to the faults and suction, which is all interrelated. Depends on the initial size and shape of the refold. some things are going to be more vulnerable to getting manipulated by these forces. So the character size and position of adjacent bodies, remember these things come all together, and many of them together is not just one isolated. Nothing in nature really is that way. Everything, comes in a series, and they kind of dissipate to nothing on the edges of where the zone is. So yeah, these adjacent bodies are likely other refolds as they form in a connected chain, as you saw in that diagram. All energy used to do all these things, to make these changes, is a result of plate tectonics, as you'll see in this presentation. So 3 common types here. You can see all these. This one is where it's starting to rotate and the tail guts is sort of getting pulled into the fault zone. It's getting sheared here. This is starting to kick up counterclockwise. This one is where everything's nice and even. You got the structure here, and it's just kind of literally going with the current. And here you have sort of a combination of things going on. You got some rounding at the top, which you actually saw on that thing I was showing you, the giant refold structure that I pieced together in New York. And you got shearing down here. And what will probably happen eventually is this will kick up too, this leg, or kind of smooth down as it becomes more like that. It really depends on so many things. So here's that structure I was just talking about. And like I said, I started noticing these things. If you look at this, if you live on the east coast of the United States, you're going to say, wow, that looks mighty familiar. This could be Mexico in the shearing area, Gulf of Mexico waterway, Florida, North Carolina coastline. This could be like Chesapeake Bay or whatever, where the coast kind of kicks in a little. Then you got the northeast where it kind of comes out again. New Brunswick, Canada. The St. Lawrence River would be here. This structure, like many of these structures, are separated by faults. This is a fault. It's a right lateral movement. Here's that, the Mississippi River here and the Ohio River coming together to continue the Mississippi River going into the Gulf of Mexico. There's internal deformation in here, as you'll see. You can see the flow going on here. What's causing the bulging is it's flowing down this way, and it's butting up against this force coming here, so it's compression in here and folded up. All right. Okay, so all this work that I've done, there's relationships to things on different scales, and this is the concept of fractals. So here is a location called Upper Pound Swamp. It's really a lake, showing refold characteristics. This is in Bear Mountain State Park. All right, this looks like one of the things we just saw. You can see there's some a shear zone in here where the tail is getting pulled out here, and you can see the arm is starting to kick up. There's that rotation going on. This probably, when it started out, it had that basic form like a crescent moon like this, and it's become altered because of fault zones nearby. All right, there's some internal compression where you get this kind of thing going on, and there's this Mississippi and Ohio River confluence that it's kind of mimicking, as you'll see from fractals, because this will be duplicated on the east coast of the United States. But not to jump too far ahead, now we have this internal structure, like I was saying. The Mississippi River, below the confluence of the Ohio and Mississippi, flows south-southwest. So hey, look at that. There's something going on here. It's that compression zone, just slightly dissipated. But this is where like the Mississippi Delta would be. And there's a reason, the path of least resistance. Why did it choose there? Because that's in between two things. Things tend to occur on boundaries between things. So there's a reason your Mississippi River is going to go that way. So this is a concept of fractals. You'll see on the next slides what I'm talking about. All right, there's that structure that I mapped. I pieced it together, got rid of all the internal faulting and all that, and determined that here it is. So where this is somewhere in here. There's a little this zone, but you can see the similarities. This is like a infinitesimal, like a basic form of this. That like this would evolve to that. This is more complex. There's more rotation going on. Everything's more severe, but this is a concept of fractals. Okay, so where this is this area right here. All right, and I'll show some more areas where these features are. These are rock outcrops. You can see that there's tight and very tight folding. This is very tight folding here. It's actually like almost on top of each other. The layering would go like this and just go right back. You can't even barely tell it apart. And it's buckled up and everything because of the refolding. It's a very tight folding with brittle jointing between resistant sections, similar to internal zones in North America. As you'll see, there's a lot of internal zones. North America was separated into zones. It's the most complex continent, as you'll see. So this is a good example of a joint separating a zone. You can see like a zone here and a zone here. It's always going to go between. Like I said, things kind of go between. This is a weak joint that, for some reason, there's always a reason that something exists. I'm not sure what it's separating, maybe a little thing in here, but there it is nonetheless. All right, this is I call it a tight fold. These are both in the same area. This is what's called boudins. You see a lot of this in this presentation. They're indicators of material flow in an extensional environment. So you have these resistant things that are along a pathway, and they're separated by, I just drew a line in, but that represents the path of flow. Very important principle. Okay, so these boudins are all over the place on this map that's like 6 miles by 4 to 5 miles or so. I pointed out some of them. They might be a little hard to see, but just the concept is they're on different scales. These right here, I call them nap structures. I'll go over what a nap is. Actually, it's right here, I believe. The boudins are in here. The nap structure's here. Okay. This is what I call nap structure. Like I said, I'll go over this later. Okay. Just to clarify here, you have your refold from the two stress directions and perpendicular directions. There's your most basic form of refold here in blue. What we were looking at before in that outcrop is the light blue line, the thin blue line here. I call it tight folds in the photograph. So in case anybody's confused as to what's going on, that's what I'm talking about. Okay, so when you go to different parts of the United States where this Precambrian rock is, this is all Precambrian rock. This is not Precambrian. I believe this is definitely not. Yeah, this is not. You can see these, what I call are refold structures or boudins. Doesn't really matter. But you can see a flow direction, and everything's getting pulled into this zone here along this stronger dominating fault zone. There's a weaker one here, stronger one here. Okay, so you can see that flow. Now what's going on here is there's a step in this weaker zone, goes like this, and as this, there's a flow direction for this refold structure. It was going like this, went down, and the leg got kind of kicked up here, from here to here, as it got attracted to this zone here. And of course, because like I said, depending on other refold structures' existence, it's going to go between them and everything. So that's what's going on. All right. Refold structures, Boudins likely moved, now brittle and frozen. You can see it's almost like a snapshot of time. They were frozen as they were flowing, and then as the rock got closer to the surface, it became brittle and froze up, and then all the deformation features and everything associated with the rock will be brittle. It'll just shatter as opposed to flow. But this is like recorded history of what happened at one time. Fractals, how large scale are these refold structures? Well, North America is a refold structure. These are these zones, extreme rotation going on. Okay? I numbered these zones. One is, there's a master fault here. Everything's moving towards the master fault. The San Andreas is over here. What happened was, this is what started it all. It looks like a intense shattering area here. And normally this is the hardest rock up here. This is all old Precambrian rock. You don't just have a big hole in the Precambrian rock where there's water. Water means there's a weakness. So there's a perfectly, if you look at Google Earth, there's a perfectly round area here. So that's where I drew the asteroid. And it's almost like you can see it came in this direction. It destroyed that area, and you can see almost a directional thing going on here. And by the way, there's like a little meteorite that hit in Chesapeake Bay here, right in line with it. I don't know if it has something to do with the same, maybe a series of meteorites. But anyway, the Great Lakes here, you think, oh, it's just the Great Lakes, but if you look carefully, there's a rotational feature, counterclockwise, like everything's counterclockwise. Number one here started there, and as it advanced, it flattened out and moved up. So there's number two, which is associated with the other Great Lakes. So that, like, there's one is formed from whatever lake that is, and then the other one is formed later from other lakes and other features. All these borders of the zones are along seismically active locations, water, faults, lineations, etc. I didn't just draw these in, there's reasons they're there. There's the Mississippi and Ohio River controlled by the Refold forces. Now everything's coming down this way, you can see the arrows. So it's also going up that way to come back down. So there's a pulling here. That wants to go that way, that wants to go that way. And everybody knows in geology that the Mississippi and Ohio River was formed in a tensional environment. It's an old rift. It's called a rift, R-I-F-T, rift zone. So there's the Mississippi. Flows south-southwest, and the delta's here. That's the Mississippi, which ends up coming from that area. The Ohio River's that way. There's always a reason for everything, like I said, especially the big rivers. So let's see, there's other important things here that I will get into more later. The rotational track of South America's sheared northern edge due to counterclockwise rotation. I don't want to jump ahead, but you're going to see this on a slide later. That line right here is where part of South America broke off, and these are actually Boudins, and they shifted from this area to that area counterclockwise. And there's also a rotational track of North America, which is here. And this looks like a Boudin here, things are getting pulled in an extension zone here, so it's separated out as a boudin. And that C is yet another asteroid, the one that they think killed the dinosaurs. They hit in the Yucatan Peninsula. And it might have caused more rotation, because these asteroids are associated with rotation. Okay, I think that's everything here. This is a very busy, important slide here. There is one more thing. Jumping ahead a little bit, but there's the slither of land on the one side of the San Andreas, which is here, the master fault, is the sliver is small. So, being that this is moving, the massive land is moving more this way. This might be sort of stuck, not moving as fast because it's small. And there's also an influence from the Mariana Trench, which I'll get into later, that's pulling this way. So that's why there's that difference. This is another right lateral fault, and there's a difference, and that's why that's going that way, at least relative to this mass going this way. See that? All continents are related to refold structures, and here's why. See the next several slides. Okay, some background information. Precambrian era rock is what's really controlling these refold structures, what they're comprised of, these original continents. Basement rock, I call it, is the deepest and oldest rock, this Precambrian rock. On a continent scale, and often more, the Precambrian rock controls the character of the younger rock above it, especially while in a ductile or mobile state during tectonics. Surface rock, the highest rock, is often not Precambrian era rock and has been derived from the Precambrian rock, has to come from somewhere. As a starting point, during the rock forming cycle, Precambrian rock is either eroded or melted to form these secondary rocks on a higher level. It must be understood that this presentation is about the controlling Precambrian rock as the foundation rock that controls the superficial rock. Okay, this NAP structure that I was talking about. A NAP is defined as a large sheet-like body of rock that has been moved more than 3.1 miles or 5 kilometers above a thrust fault in a compressional environment during plate tectonics. So it's a big area, sheet-like body. So as you can see here, rock is initially undeformed and flat, and then this thrust fault comes along and it's compressing the rock and starting to fold it. Call it stage 1. Stage 2, and really several stages, there's more intense folding as it continues to move. Thrust fault is a large low-angle fault, which you got here. These fault splays dissipate fault movement over an area. So things are going to be, dissipating to nothing. It's not going to be like very intense and then nothing. There's like these slow dissipation of what's going on. Final stage refolding from a separate event is what happens with the refolding. Remember, there's 2 different directions for the stress, right? Okay, so in regards to fractals, I put these circles here because this could be like, this could be 20 miles here or whatever it is. All these folds, each one is maybe a couple miles or something like that. And where the circle is could be quarter mile, and then maybe you have a rock outcrop here, or like something larger, and then you have a rock outcrop here. And these folds go all the way to the microscope. That's the principle of fractals. In regards to that final stage that I was talking about, that final stage event where things are refolded, it's from a separate event in which the force is perpendicular, as you saw before, to that which caused the NAP structure. So it's 90 degrees to it. Remember that NAP is a large sheet-like body of rock that has an extensive area in which formed structures must dissipate to no deformation on its borders. Things in nature just dissipate on its edges. You don't just get some zone of whatever and then it just stops. At least in its initial formational stages, things just dissipate. The separate event was either a sudden change in plate tectonics or an impact asteroid. Not saying that I think it's plate tectonics, but or an asteroid, I'm sorry, not saying that necessarily, but in most cases with plate tectonics, the events are somewhat gradual, incremental, because they are across an interdependent connected chain, as you'll see in this presentation. If all continents are refold structures, what happened to the rest of the area around the highest area of deformation in the refolded nap? What happened to the numerous rows and columns in the zone of refold structures after the refolding event? This refolded area of high deformation must be quite vast, to say the least, and it must dissipate gradually near its borders. So what happened to it? The answer, the original rock, was from a much larger planet that had plate tectonics and life. I'll discuss the part about the life coming up. So one very long column, this column, broke off from a very large planet that had all this refolding from two separate events. This planet had recorded life in its bedrock as evidence of stromatolites, which we find on the Earth in this old Precambrian bedrock, in these type 2 refold structures. Each refold structure represents original connected continents on the Earth. This refolding occurred on a very large planet, not on the Earth. This planet likely had plate tectonics active either previously or when it broke up, as evidence of the metamorphic rock types found that were originally thought by geologists to have formed in similar environments as what we have on Earth today. The easiest way to break the refolded sheet-like nap is along a column, as shown in red, rather than along a row. So it's much easier to break something off here than it is to go across. All right? The column or chain of refold structures rotated into a coiled circle, which I'll show on the next slides, and connected at the Mariana Trench, which was originally between Southeast Asia and Russia. The original Earth had no oceans, only shallow seas and water bodies. The planet was only the width of the refold structure's chain, which came together at a rotational locking mechanism on each side. The planet expanded after plate tectonics occurred. Plate tectonics on Earth was initiated by a large asteroid that struck North America. Each refold structure is more or less on the same order of size, as they fit best this way, and they form a relatively stable chain of refold structures. A refold structure is shown in blue. There's your basic form again, and the column that would break off. And of course it'd be several, this is just a diagram, it shows a 3 by 2 column, whatever you call it, 3 by 3 row and column area here, but it's going to be a very vast area. So this catastrophic event on the large planet, probably one of many, but the smaller events just caused or continued the plate tectonics. The biggest one, like what I believe happened on Earth, initiated the plate tectonics. But this one was so severe that it just obliterated at least a section or the entire planet. And these chains broke off. The one in the blue would be something that would form the Earth. And like everything in space, for whatever reason, they start rotating. I don't know if it has to do with charge or whatever, but eventually it coils around, and it's securing itself by locking up with these mechanisms that you'll see on the next slides on each side, because it's we have like one refold structure width, so they have to lock up on each side, and they stretch, they accommodate to join and become stable, and then internally they're stable because they lock up here. The coil is in contact with itself eventually for greatest stability. So as it forms, it's going to do things to cause its own stability. So the solid blue chain is that which formed the Earth. It is a stacked column of refolds from a zone of refolds. What happened to the numerous other chains? Maybe forming the other planets or whatever, I don't know. Note, it is possible that this large planet had a coiled structure just like that of Earth, and that its refold chains were recycled from another planet, or that the asteroid caused the refolding of a pre-existing nap. So here's a very exaggerated cross-section, and this is the order of these continent/refold structures. you start with Russia. It's pretty much strictly Russia. I'm just calling it Russia, but next one down, North America, then Africa, South America. Actually, it's Antarctica and India and Australia and some other sections of land. Continent A, which I'm calling it Continent A because it's no longer present. It got pulled into the Mariana Trench, which you'll see on the following slides. And you have Southeast Asia, which includes Indonesia, China, Sumatra, Japan. So that meets up with the Russia refold, and it tucks in, goes inside the Earth. It probably gets generally smaller because to fit best, things will generally either get smaller or bigger. And you'll see on the following slides that this chain has to kind of gradually get wider or gradually get smaller. So in regards to plate tectonics, melting occurs with depth due to heat and pressure. This would be along refold contacts, subduction zones where there's compression, extension zones where the oceans are forming tension, shearing zones. So when the asteroid hits, after tectonics was initiated by an asteroid that struck North America, as you saw, faulting between the continents, refold structures developed. So the faulting is going to go, the easiest place to break anything here is between these more or less resistant refold structures. So path of least resistance is between them. All right. And at the time before plate tectonics, there was just shallow seas, water bodies between the continents. That's the weaker, like the joints or whatever of the structure between. So there's just going to be shallow seas there. And after tectonics, there's faulting and they become oceans through faulting action. So the Mariana Trench is where they join, where the structure gets tucked inside. Okay, in nature things want to go back to the way they were originally. So these things, these refold structures, as you saw, they look somewhat like this, where they're tightly folded. And this is just probably not folded enough. It's just, well, I know it isn't. This is just to see things that are going on. And again, it's an exaggerated cross section of the Earth, where it comes around and it wraps back in on the Mariana Trench here. Okay. So you have stage one, they're all connected, there's no faulting, there's just shallow seas here between. And you go to stage two, right after the impact, after the asteroid impact and plate tectonics begin, the faulting begins and ocean development begins right between. The ocean crust is thin and dense, and it fills between the refold structures. Now what's going on is the refold structures want to rebound because originally they were not this tightly folded. So in the ductile state and all, they just want to go back to the way they were. So there's going to be always this uplift here with these arrows, and there's more of a brittle zone on the top because there's less heat and pressure, a ductile zone at the bottom. All right, so what happens when there's any kind of change in science? The reaction is, okay, so this is rising up, so let's take that material and fill in the gaps. We're going to try to make a flat surface. So anything that rises up, let's erode it quickly. So it's sort of fueling itself to form the oceans and fill them in with sediments and things. So it all kind of makes sense in that respect. And you have stage three, they actually get fully separated, and as they're brittle, they'll just skate off quickly to Mariana Trench or wherever they're going, because there's nothing stopping them. They're separated, independent. Okay, so I discussed this. The continents erode and fill up the oceans with sediments as uplift and unloading proceeds. Structures may deform when ductile. They may be mobile and pull the chain of structures when shearing or by suction. The separated structures freeze up when brittle and drift by suction. Okay, so I made these clay models and I'm going to show the modern day Earth with these refold structures shown on them. And basically this is like the chronological order of the plate tectonics. So the time scale, this is crazy, I have no idea. Okay, so these are all the exposed continents slash refolds on the Earth, from Russia to Southeast Asia, where the Mariana Trench is, or it wraps around this part of Southeast Asia to Russia. You have an idea how long this chain could be, because there's always this gradual kind of increase in width, a gradual decrease in width kind of thing going on here. All right, and actually, again, you can see the basic characteristics of these refold structures. So you can have an idea. You're going to see that these are going to be the most stable ones. North America is going to it's going to be moving a lot because it's long and skinny, and this is going to move. It doesn't look too stable as it is here. So there's no plan view of the pre-plate tectonics Earth with the two interlocking mechanisms, because it's sort of not feasible to show it. You'll see in the next slides what this interlocking mechanism is and what's going on, what I'm talking about. So after this asteroid hits North America, right about here, you'll see that it's on the left side. So there's a difference if it hits on this side versus that side, because things are going to start rotating counterclockwise. Here's Russia, North America, Africa, which actually, I say Africa, etc., because some of the material ended up in Middle East and all around up by Russia and everything. South America, Antarctica, India, Australia, continent A. Now, okay, so like I was saying, it hits over here and this leg kicks up. These two locking mechanisms snap apart, and as they snap apart, things stretch back. These refold structures stretch back to their more natural kind of sizes and sizes and shapes and all that, because they were under a lot of tension trying to lock up for the locking mechanism. All right, so you got this leg kick here, and it starts to rotate counterclockwise. Now Russia rides along. You see it's kind of moving with it, and this slips a little too because this came this way. This is the end of the chain, so relative to this Southeast Asia, this Russia slips this way, and Africa and South America remain very stable. This one opens up a lot. This Antarctica, India, Australia opens up because there's plenty of leeway here, and this continent A to not such a great degree, but there's plenty of leeway there. All right, the next stage is just continued movement. Now this is pretty crazy because North America was across here, and it went that way. It whipped its way through and ended up like this, and vacated its position above Africa and deformed the edge of it. This tremendous deformation in here, just like that. And the leg went this way and whipped up here. There's a rotation going on, and it pulled Russia with it, and this continued the movement clockwise here because it slipped so severely, and the suture here, which is between Russia and Southeast Asia, opened up, and that drove more suction, because as this rotates clockwise, it's going to want to go back to where it was, so it's not in a very natural state, so it's going to cause excessive suction. All right, and some material from Africa is trying to heal the suture. Earth has a way of healing itself, so it's coming to the rescue, so to speak. So as you see, there's only minor deformation. There's evidence of this, as you'll see in later slides, in South America, as Africa just slipped a little bit. Now this Antarctica, India, Australia continent here moved like crazy, and it's forming the shape of South America here, and it's starting to follow the suction zone here pretty severely, even the end of it, which is kind of affected by this movement. It's all connected, as you'll see on the globe too, but in this continent A here, which the one that got sucked into the Mariana Trench, that kind of stuck together with this continent, but it's really shifting around a lot too, and it's showing signs of this ductile movement into the suction zone. See this here too, this is, things are pulling up into the suction zone, and this newly created thing tearing the suction zone here. This is Russia's pulling it along. Africa's coming to the rescue, putting material in here, and this is rotating this way and opening up the suture, which was over here, and it's kind of pulling it. You'll see on the globes I put it in red. Okay, the next stage, things continue. The original suture is stretched even more. There's more of this clockwise rotation. So it was here and it got pulled over this way. Original suture stretched and rotated as Russia is dragged and Southeast Asia is rotated. This is Southeast Asia, this is Russia. The arm grows, the arm of Africa here. America starts rotating off, and as you know, North America, South America start coming together. The mid-Atlantic ridge is going to start forming and working its way in. So this really mobile refold here, which is Antarctica, Australia, and some other land, and India. This became India, has zoomed off even further, and in the process, this continent A arm is affected by the suction. It finds its way right between. And look at the structure of Antarctica. Everything's sort of adding up here as it's showing signs of getting pulled by suction. So this Antarctica, remember, it zoomed out, this way, and it's starting to just get pulled into this suction zone. And it's separating. This is like ductile separation here, because it's still ductile characteristics. There's bending and curving and all that. It's not brittle yet. Later on it gets brittle. Florida shape is starting to form on North America. There's where the meteorite hit. There's some suction coming in here. Some material came off of South America, as you'll see in more detail about this later, but it ripped off here and it's starting to rotate this way out in the suction zone. So this is all one continuous suction zone, all tied in. Note, suction forces acting to affect the refold structure's characteristics and shapes. Everything, there's reasons for all those shapes, because they're getting manipulated by the different suction forces. They translate both for plan views, as you saw, and globe views, as you'll see. There's no plan view that I made of present-day globe. I have just the globe itself. I didn't do any clay model for that. No need to. So this interlocking mechanism, prior to the asteroid impact when Earth was stable and much smaller, shown here. What is going on is these continents are stretching to accommodate stability. They're wrapping into this locking mechanism. This is North America and Africa. They have a bigger role in this locking mechanism because they're bigger continents. Bigger refold structures, really, is what they are. The interlocking structure is due to the nature of the rotation. Now, you have between Russia and Southeast Asia is this Mariana Trench. So it goes this way: Russia, North America, Africa, South America, Antarctica, India, and Australia here in this continent A, and Southeast Asia is where it tucks in. There's a little more water there because that's like a much weaker spot. Water is going to gravitate towards that. But this is exactly as it's shown. Here's Russia. Everything wraps around this way, and at the Mariana Trench goes inside, and it'll continue wrapping. Okay. The other side, same thing, you're just looking at another view. Here's Russia, and here's Southeast Asia, there and there. So it's going to wrap around this way, Russia to North America, etc., wrapping in. Coils inside itself, just like that. So actually, I should have said this on the other, but because of this nature of coiling, it does that. And on the other one, looking at it from the other side, it does this the other way. All right. So the evolution of the size of the Earth. I was explaining how plate tectonics causes expansion in the Earth. These are the globes that I made. Before tectonics is the first one. Very small, no oceans. Then the buttons bust off the locking mechanisms, and the oceans develop at the where the buttons pop, so to speak, on each side, one side, two sides. North America leg kicks up. So oceans are coming in, it's expanding rapidly. And then this continued motion where North America whips through the top of, really the side of Africa and deforms its edge, and then it continues rotating like that. We'll get into more detail later, but while all this is going on, the Earth is expanding and accommodating this movement. Here's the final globe here. I show the refold structures on that, as you'll see. Relative size of the Earth due to plate tectonics and subsequent unloading of the tightly folded refold structures. I discussed that previously. So the evolution of the continent's refold structures in order from the top of the chain structure, Russia, to where it coils into the Earth, Southeast Asia, are going to be shown on the following slides. I wanted to do this because this way it's on record, you can see things better. Take your time seeing it. It's hard to show a globe and show everything, and these clay globes, I should call them, they could get destroyed or smushed or whatever, so this is a good way to keep permanent record of them. So evolution of Russia, the orange color. This is the first one, shallow oceans, no plate tectonics yet. And that's where the button snapped, and you got your slight shift because North America leg kicks up here, and it shifts slightly this way. There's that suture, it's getting pulled a little bit. It's between Southeast Asia and Russia here. Continues, the Africa arm is coming in to heal up this suture, opening up, and this is rotating Southeast Asia. So there's Russia, continued movement this way, really because there's the suction from North America rotating that way. Everything's tied into, really, in a sense, one suction movement, but it's all connected. Okay, as you continue, there's more separation, more water and everything. Things are rotating this way, and that suture, Russia came from this direction. It's continuing its movement. There's some flow structure going in. That suture is continuing to open up. There's Southeast Asia here. So this is the modern globe. I put in the refold structure. So this is Russia right here in the orange, and we'll see more detail on this later. The material from Africa really kicked in here, and everything's tucked away, relatively, seemingly more stable. Evolution of North America, yellow. Same thing, beginning. A little shift going on there. There's that asteroid. Leg kicks up. That's right after the impact, and buttons popped on each side, and the ocean's developing. Okay, yeah, so this is the asteroid of North America, and this is after it slipped through Africa this way. And next slide, let's see. So there's just a different angle there, and this is as it starts to really rotate, the oceans expand. Mid-Atlantic Trench is coming in here. All right, so you know, who would think that North America looks this way? You can see, did look this way, I should say. Florida starting to come into play, Gulf of Mexico here. Different angle. Different angle. I just made another structure here to sort of, since this changed like crazy, I just put in sort of just before what you see today, kind of North America. Gulf of Mexico is really developing. There's North Carolina there, the East Coast. Sort of a little distorted because it's on a globe, but there's another view of it. Another view. Okay, so here's the final one today. We saw this before. You know, this material's rotating that way, and there's an arm there. And again, these refold structures, just as a reminder, don't exactly look like the continent, but they're close. If you look on Google Earth, you'll see this arm here is not exactly on the land. You can see the lineations, I guess you would call it, on Google Earth that indicate this arm here. Africa, gigantic. This is the beginning. This is where the just after the asteroid impact. This is right after North America whipped across one side of it, and it's doing that to the edge. It kind of grinded up against here and caused this on South America. Different angle. Different angle. Different angle. Okay, so this is advancing further on the next globe I made. Okay, same thing, different angle. Different angle. Okay. So that arm is really stretching up now to heal everything. You can see the suction coming in. This is what ended up as India. It slammed into the arm here. And there's Africa in great detail today. It's getting pulled a lot, so there's thin and thick sections. This is the suture, by the way. You'll see it on a few slides, coming slides where I put it in black. And it's not like a hole in the earth, but material filled in, but it's the suture zone where the arm tried to, this arm here tried to heal up the suture zone by filling it in. And it used to be a lot bigger in here, but this came in and filled it in. And everything's kind of gravitating towards the suture. You'll see on another slide too, everything's coming in at it. These forces are wrapping in. And by the way, here's Southeast Asia rotating clockwise. It used to be same orientation as Russia, and it rotated clockwise as the arm came in. Another angle, another angle. Okay, South America, relatively stable continent. Beginning, this is just after the buttons popped, I guess. Yeah. Continuing, this is when after North America slid across Africa, and you got some deformation here. Then the deformation was worse in this area where the material got ripped out. These are bootings that got ripped out. They eventually worked their way over here, as you'll see. Okay, so following suction forces again. Suction forces going this way. Different angle. There's the final one now. Okay. Yeah, you see these boudins now are lined up over here. They started over here, and the other globe they were in this area or whatever. Now they've gone this way. Everything's always counterclockwise, except for Southeast Asia, really, that's clockwise. Antarctica, this is the real mobile one. Antarctica, Australia, India, cream color. This is the beginning. This should be right after the buttons popped and the oceans are forming. Another view there. So this is when further along, when it's really starting to move and some other forms are coming. Continuing here. Another angle. Okay, this is when it breaks up again. There's that suction zone here, and it's all coming in really to the same suction zone. Different angle. And this is India here. It slammed into this arm of Africa. This is Australia here. Hi Jada. This is Australia here. This is this material you'll see on another slide. It's like a ductile remnant of what was attached here. This is Antarctica. Thank you, Jada. Okay, this is Antarctica here, Australia. Another view of Antarctica. So continent A, purple. That's the beginning. This is after the buttons popped on each side. This is the one that ended up in the Mariana Trench again, continent A. So we're advancing through. Okay, this one. Anyway, advancing through, I think this is the third globe. You have these indicators of suction here. This is rotating up, it's even starting to pull these continents here. We're looking at this one now, but so there's where the arm is feeling suction here, and there's even like another thing going on here which is causing that. That is probably related to this. There's a suction going up this way, and there's one going up that way. But they're all tied together, like I said. Different angle, different angle. Okay, the following two images are from the present-day globe of the Earth, are the final state of continent A, before it was pulled into the Mariana Trench. There's like a footprint there you can actually see, if you look very carefully. So there it is in purple. That's what it looked like. It actually shrunk a lot from its original size, as I'll discuss later. Mariana Trench is in here, formed because this Southeast Asia rotated clockwise, and it wants to go back the way it was, so it's causing suction in here. Tremendous suction. So there it is, another angle of it. And as you'll see on other slides, this actually left the remnant of the Mariana Trench, left the signature of it. The Mariana Trench is kind of arced. Southeast Asia, green, showing the distorted and stretched red suture where it connected to Russia and where the Refold chain coiled into the Earth. There it is. And it's so now starting to rotate here. The suture is getting pulled up a little. So now it's really rotating a lot. You get this stretching of the suture zone here, which is originally here, and it's again kicking clockwise. I'm sorry, in this case clockwise, because this thing, the nature of it, the way it was when this arm of Africa hit it, it kicked it out this way. Just another angle, another angle. This is where it's still going to continue to rotate. Let's see. Yeah. So this is more severe. You see this came up even more here. Almost like an independent suture. Same, different angle. Okay. There's a good view there. It's really kicked up. Original sutures this way kind of opened up a little and really came up like that as this rotated clockwise. Here it is on final globe again. Another view. Another view. There's that continent A ready to get pulled in. And again, it already did. This is just there to show what it looked like. Okay, this is the pre-tectonic globe, the first one with the interlocking mechanism. This is where, Africa, the bigger continents kind of pick up the slack on the interlocking. North America, Africa. Got the shallow seas between the continents. They're sort of like, collecting the weak spots. There's a bigger one at the suture between Russia and Southeast Asia. This is where it goes inside here. And again, where it goes inside kind of affects this interlocking mechanism in this way. And goes inside here, so it affects it that way. Okay, so after the meteorite hit, which is shown here, hit on the left side, therefore it kicked everything up this way, made counterclockwise rotation. Kind of shifted things around, shifted Russia a little. That suture got a little bit aggravated, kind of with the movement there. Ocean's opening up at where the buttons popped off, so to speak. So that's it for that. Okay, this is where America scooted across here, grinded up against Africa. A little bit of grinding here from the rotation, everything counterclockwise. Russia slid along as North America moved. The suture got aggravated and extended as Southeast Asia also rotated clockwise in this case, because the arm of Africa came in and did that because of the nature of the way this was before. It was kind of like this, so it went that way. The supermobile Antarctica and what became India, Australia, and some other section next to Australia. It's right here. Up into things are moving up into the suction zone. All the detail is there. There's the suction zone. It's really all connected. I can't say there's little subzones and everything. Even the detail here, there's a suction zone in here. Tied right into there, you can follow the ocean. Okay, next one. Get off there. Okay. This one is massively heavy. But things just continue. That arm of Africa grows. Kicks Southeast Asia even more, counterclockwise. Suture opens up even more. I should say sort of divides. It's sort of like two areas of the suture. This continues to go this way, takes a ride. You can see the dynamics of flow. Dynamics of flow are there on the Southeast Asia too. Oceans continue to grow. Mid-Atlantic Ridge is probably coming in here. Actually here. Wait a minute. It would be between South America and Africa. So it hasn't come down here yet, but it's starting to come in. North America starting to show signs of a little bit about what it looks like today, sort of what it looks like today. There's Florida, Gulf of Mexico's here, East Coast. Eventually there's material that's going to whip around and look like Alaska. It comes off here and goes up there. There's that suction there. That continent A arm is right there. You can see the shadow of this on Google Earth. The shadow, I should say the footprint of it. You can see this on Google Earth. There's a ductile breakup of Antarctica, Australia, and some extra land, and India. This is India. Yikes, this is really heavy. Goes into Africa arm. Here's a modern globe. A lot of detail here you see on the other slides. It's a little harder to see here. Things are hard to fit, but it's all here. Because it's a globe, it's hard to get this tracing paper on real well. Here's Africa. There's that arm that shot to heal the suture. Again, look at Google Earth. Looks like this. You can get the detail out of it pretty good. Here's Russia. India went slamming in. Here's Southeast Asia. Was this way, rotated clockwise that way. Mariana Trench here. Super amount of suction because it wants to go back, but it can't. So it's stretching that suture. Here's Australia. Here's like a ductile section. I'll discuss this later. Like a remnant in here. That was attached here. Antarctica. This is continent A. Footprint. Doesn't exist. It got sucked into the Mariana Trench, which left its mark more or less. It's right over here. Looks like that. What did I miss? Here's North America. The material here whipped across here. There's more rotation in here. So this, these Boudins came across final state as you see it today. Right? Okay, so how did I determine the evolution of the Earth? You might be thinking, what the heck are you talking about? How'd you come up with all this stuff? Is this what you want to see? Is this what you want to believe? I used Google Earth, viewing different angles, lighting, magnification to see present-day features, including these footprints, scars, and other evidence of past events, and physical entities such as Continent A. Continent A was crucial, because it kind of filled in the gaps and everything. It showed the dynamic history of these things. Reverse engineering, of course, from relatively clear present-day refold structures, which some of them are surprisingly clear. And they're showing the flow dynamics and sharing evidence from the past. Application of various geology and science fundamentals. Discoveries started from the New York area, then to the East Coast of the United States, then to North America, and then to the other continents, refolds. Sort of like an unraveling. Hence the name of the presentation. So, present-day Earth, you're going to see some slides here in great detail of the present-day Earth with features showing evidence of past processes. Okay, here's that asteroid. Very, very round section of land here, which does not happen in nature. Not in the hardest rock. This is all Precambrian hard rock up here. So this thing made a big hole, and you could actually see like the path that it went, which is actually in line with, more or less in line with another asteroid, the Chesapeake Bay asteroid. So this is the northeast coast of North America, and this is New Brunswick, Canada here. Now what's surprising is there's actually continental drift very close to like metropolitan areas, and right in them and everything, that right before our eyes it's happening. For example, this is Massachusetts here. And they got these rocky beaches, and the land is essentially drifting off. See the arrows? This area slid. You can see this rotation here. Everything's kicking up and going into the flow here. This was once ductile layering here that wrapped around. This was what made Alaska here. The arm whipped around like you saw. So I said ductile layering wraps around asteroid impact location. We went through this before, but this is just specifics. I call this the original Refold arm. The reason this continental drift happens is water lowers the shear strength at brittle fractures in the rock, which allows break-off and drift. So it sort of takes over the properties of the rock by lowering its strength. Water has no strength, so it gives it more vulnerability just to skate off into the flow. Okay, this is South America, and there's South America boudins showing deformation dynamics of the refold structure. Boudins sort of indicate movement in extension environments. The deformation dynamics control the location of the Amazon River, which is right here. So there's some kind of uniqueness to the character of these deformation paths that allow the path of the Amazon River as such. Okay, so let's start. I determined these pathways for the boudins for the deformation by looking at Google Earth, and I was able to see that they all were rotational, and I'm sure counterclockwise, especially because this got torn off here. So let's take this path here, the black. This is where the tear off is. And it's probably influenced by the adjacent rotation of Africa that was here, that was rotating that way a little bit. So anyway, this tear off here, let's follow the black. Any boudin is going to be parallel to these deformation paths, but since there's this rotation, it kicks up. So this boudin number 1 kicked up this way. It's right here. There's actually a footprint there. You can see it on Google Earth. And it kicked up and eventually went over here where it is today. And this boudin number 2, which is with the, actually boudin number 2 is with the black on the outside. And that ended up over here on the outside. Boudin number 1 is here. And boudin number 1 came from the red here. So it did this, everything kicked up counterclockwise, ended up this way. So we'll do the black path. So there's boudin 2 here today. Follow it around. It joins up with another path. And then you go this way. And you just did a complete circle. So now we'll look at the red. Tear off here. Boudin number 1 up here. Let's follow it down. It shares a path with the orange. Then it shares a path with the black, and then it splits off there. Okay, let's follow the orange. Start here. There's some existing boudins here. You can see them. So they come around. You can see these also, and they come around full circle. There's that rotation. And this here is probably from blue line caused by dragging of Antarctica, we discussed, and pulling the arm of continent A at that one point. You can see the footprint of continent A arm over here too. So there's this extension here that probably caused all this. And it's all by suction forces. And as I said, most of the deformation paths are rotational and shared over time. They're sort of like telling the history of what happened. Okay, here's Central America, and there's those boudins that rotated. You can see the footprints like I explained. The rotational path is here. These things were parallel to those lines you saw. Now they kicked up, these boudins rotated that way, and there they are today. It connects to South America mainland here. Here's boudin number 1. It was with the mainland and it rotated this way is what I'm saying. Now North America's counterclockwise rotation moved along this path. Everything rotated like that as a big unit, as you saw on those globes and on previous slides and all. And it looks like it went up this way to sort of accommodate these things. So it went up like that. And also, there was a meteorite here, this asteroid that may have caused the dinosaur extinction. It might have caused additional rotation, but it caused, there definitely, regardless, there's an Abudin happening over here. And now there's bulldozed material. You could actually see this on Google Earth too. As North America shifted this way, it sort of bulldozed some material, and there's a line there. Same with Central America. You can see the edge of the bulldozed material. Galapagos Islands, which is a hotspot, is right on the edge of the bulldozed material. These hotspots seem to be associated with scraping of continents or material in this case. So let's see, edge of North America, bulldozed material from rotational action there, like I said. Edge of South America, bulldozed material from rotational action here. You can kind of see this thing between the two sections too, the one Boudin area, other Boudin area. You can see this line between. So I explained the rotational tracks and these footprints, as you can see. And these are existing Boudins you can see on Google Earth. They could be footprints, whatever they are, you can see these. All right, next. So this is showing the suction forces around the suture zone, which I put in black. This is Russia, and this is the arm of Africa that tried to come in and heal the suture zone. Southeast Asia that got rotated clockwise and pulled part of the suture with it over here to make the Mariana Trench. So the forces are all coming in. You can see this, they're all acting to kind of cover up this zone. Now again, this isn't a hole in the earth, it's filled in with rock or whatever over time, and you can actually see very clearly that it's, it fits the dynamics of what's going on. You'll see that on future slides. There's what's called a rift zone in here, but regardless, everything is really coming into this zone. This is kind of an independent thing going on here with Alaska, North America, which rotates counterclockwise. And it all ties into what's going on here, as you saw. But we're specifically looking at how everything's kind of coming in. See? Okay, this is just a different view here. The original suture zone, again, rotated from over here as this thing rotated clockwise, Southeast Asia. Jada, what do you want? Suture zone created by North America rotation after the asteroid impact. That's really what caused it all. I mean, the suture was there, but it caused the plate tectonics by stretching and rotating the suture zone. Here's the Mariana Trench. The structure is rotated clockwise, as I explained, after the arm of Africa struck. Movement can be seen, it's changing shape. You can actually see a dynamic going on here. This is really it here. It happened very recently, some of the movement, because this brittle movement associated with Australia, it was connected along a line here. And this encroached in after. Brittle things are very recent. So this rotation, at least the very end of it, happened very recently. So there's Australia getting pulled into where India is going. It's probably going to do the same thing eventually. So here's the suture zone again, another angle. This is the deformation of Africa. So as you can see, things kind of fit nicely. When North America made a certain characteristic here with this fold here, it was up like that, and then Russia came in, kind of flattened it out, and collapsed this, compressed it in here. So I was just saying North America is deformed. It deformed Africa's western side when it rotated along it. A small volume of Africa here may have been pulled away by suction during the rotation of adjacent North America. Material flowed to this area as evidenced by the collection of the flow of Boudins, as you see on the next slide or two. But I think it probably did not get torn off because the Boudins were collecting here because the material was kind of stretching here to get, because everything was kind of going this way. The flow was moving here, but I don't think it got torn off. It's different than shearing. And you saw shearing on South America that did get torn off. But I just wanted to note that. So now you have this arm of Africa coming in, which is now the Middle East in here. Again, all started by North America rotating after it was hit by the asteroid. Okay, here's just another view. There's these Boudins I was talking about that you can see on Google Earth in this part of Africa. More detail, the suture zone here. Everything kind of fits nicely. You can see the deformed area that is now flattened from Russia, got flattened out. Everything kind of fits nicely. You can see this kind of goes in here for the deformation. You can see the deformation mechanics, so to speak. There's tremendous deformation in the Alps. This is the Alps area. A lot of volcanic activity in Italy and Sicily, probably because of what's going on here. Things are really compressed and flattened. So just pointing out the edge of Africa Refold structure again, formed by shearing forces from North America rotation going this way, shearing along it, and then North America went out that way. Again, same note here about small volume may have pulled away, but I kind of doubt it. The material's kind of collecting here. I don't think it got pulled off or sheared off here. In fact, the shearing dissipated here, but the material flow is kind of collecting here. We'd never know because with the Mid-Atlantic ridge it opened up, anything would have incinerated. So even if something did come over there, it would have been burned up at the Mid-Atlantic ridge and we'd never see. Just another view, there's those Boudins. Just wanted to show another angle. Shows material flow, these Boudins, everything's kind of flowing this way. Okay, here's South America with continent A up against it. This is when it was stretching with one suction force going this way and there's another suction regime, really part of the same one coming this way. So there's a reason this shape looks like this. Initial suction direction before it took the path into the Mariana Trench. So temporarily it was getting pulled this way, and then later I'll show what happened with this continent A. Okay, so here's another angle. The suction, there's that arm coming up this way. You can actually see a tension crack in the arch structure of continent A here. You can see that on Google Earth. So the path is, this will be discussed in more detail on other slides, another slide at least. But it actually overcame this suction, went down, this continent A, went down, went in reverse almost, like it's doing a K-turn like a car. And then it went into the Mariana Trench way over here. So it did this crazy motion because that suction was probably so incredibly intense it actually managed to negate this and pull it the other way. The suction at the Mariana Trench. So I just showed Australia's moving this way, going to be similar to what's going on with India, which is already slammed into the arm of Africa, I'll call it. Okay, here's another angle. This is what I was talking about with the movement. I was saying that force must be really great to overcome that as it started to get pulled into the Mariana Trench. It was strong enough to manipulate the continent to reverse and then forward position. So this thing came out like that, reversed, and then went that way. Then the whole dynamic, the shape of the structure changed and everything to accommodate its movement and the suction forces and all. So it did this and then that, and then it went into the Mariana Trench. And I think there's other views yet. Okay, here's another angle, continent A. So again, the arm is up here, which you can't see. It's stuck to Antarctica, and it got the force of the Mariana Trench suction after the rotation, clockwise rotation of Southeast Asia was strong enough to put this, to make it get pulled this way, and even though the arm of it's getting sucked that way, it pulled it that way, put it in reverse, and then went into the Mariana Trench. Something else going on here. This brittle movement is very recent, but even more recent is this movement of the encroachment of Southeast Asia. So we know that this is very active because it, see the arrows here with the brittle movement of Australia. It was connected here, brittly separated, and it's going to be, India broke off and smashed into Africa's arm this way. But anyway, this happened very recently as evidence of what you can see here, because it separated, then that came in Southeast Asia. See the arrows. There's like a little ductile zone that I think is still in there because there's no evidence of it going in there. It just kind of got stuck. The brittle zone broke away. There's a little ductile zone of what was all connected here, as you saw in the globes before. Okay, so here's just before continent A got sucked into the Mariana Trench. You can see the shadow footprint, or whatever you want to call it, on Google Earth. I call it the last state of ductile continent A prior to drift, where it really went quickly into the Mariana Trench and left its mark like that. These things match up. You could actually see the scars of where it went in. It matches up perfectly. I'll say the contact points here. Just to get your perspective, here's Alaska, Russia here. There's that everything I was just discussing with Australia. There's that ductile zone here. There's like a contact zone in here between. It's probably defined by all these continents moving around. There's like a compacted kind of zone in here that isn't a continent. You have the ductile zone of Australia here, compacted zone here, and you got this flow going in this way, so it probably made this nice ridge and all. And that's the thing here I was saying on the previous slide about how there's recent movement, very recent, Southeast Asia, and the suction with the Mariana Trench must be very recent. Severe, I should say, severe suction. Okay, so continent A was significantly reduced in size during its ductile phase, which includes paths 1, 2, and the first part of 3, when it was ductile. And then it kind of froze up and went flying in as it was brittle, flying into the Mariana Trench in the last, in path 3. During its brittle phase, the end of path 3, it rapidly got sucked in the Mariana Trench and maintained its size at that point. But if you look at these parts, this is how it changed. This is, again, you can see the shadow footprint of this original continent A here up against Antarctica. And you can see this just before it got sucked into Mariana Trench. And you can add up, you can see how the different components changed. I put them in colors. So you might want to take a look at this on your own later after this presentation. I won't bore you with the details, but it's all color coded. You can see how it changed and why, because it's this flow regime. There's a reason it's shaped as it is and all, how it changed. Okay, there's the approximate size, change in size of continent A from its original shape and position adjacent to Antarctica on the left, and South America, adjacent to Antarctica and South America on the left, to the size, but not the shape, just before it was pulled into the Mariana Trench on the right, just to give you an idea how much size it lost. Okay, French Polynesia is a hot spot, and it is at the center here of all what I'm going to discuss now. And that's where there's excessive grinding from path of continent A. And the path is numbered. This is what I was talking about before. It comes down, and look how it's parallel to that red lineation. These are lineations right near French Polynesia at the center. So I think this kind of marks the path of continent A. It's scraped or whatever. It came this way, went in reverse, and then went forward into the Mariana Trench, which is over here. Hawaiian Islands are a hot spot too. It was right on the edge of all this. These hot spots always seem to be associated with contact and all edges of things. And there's also another one here, the Marquesas Islands hot spot. So these hot spots, I believe, are associated with the movement of continent A. And these lineations too kind of mark it. See how long they go back. So you got the path 1, path 2 reverse, path 3. There's actually 2 of them too. 1, 2, 3. And then it went up that way. So here's the ring of fire, association with continent through continent shearing or suction forces, but not extension forces. Wherever there's extension, which is on this side of North America and this side of South America, you don't get the ring of fire. You get it where there's the grinding of the continents together next to each other at one time. All right? So this side, I noticed, this side of the yellow line is continent-to-continent suction forces. And on this side is really associated with the shearing forces when they were grinding up against each other. So it's almost like a division line here. And the hotspots again are contact points. Marquesas Islands hotspot excessive grinding from continent A is about right there. This is Hawaii here. And you saw French Polynesia is kind of in the heart of it, but that's another one. Wherever that is, I think it's here. Okay. So basically with modern, what we read in textbooks for plate tectonics, they're really talking about zones that are associated with these refold structures. Plate boundaries are zone boundaries rotated to the driving mechanism. Oh, related. Plate boundaries are zone boundaries related to the driving mechanism, refold structure movement. So that's the difference between what I'm explaining. I'm explaining the mechanism, whereas plate tectonics describes kind of just zones, and they think convection currents are the kind of a driving mechanism, which is seemingly not the case. This is Earth's magnetic field, showing Africa. There's the North Geographic Pole here, the North Geomagnetic Pole here. This is supposed to say South Geomagnetic Pole here. It's a typo. But you can see it goes in this line here. Now, as you've seen in this presentation, Africa is pretty much stable, and it only rotated a little bit in this counterclockwise direction. And this seems very much a coincidence, but those buttons that I was talking about, the locking mechanism, seem to line up like this. So I don't know if there's any significance to that or if it's a coincidence, but I just figured I'd point that out. Discussion. For the first time, plate tectonics driving mechanism has been proposed in this presentation. Geology only acknowledges that there are zones or plates that grind past each other, and that convection currents in the Earth are likely the cause of this. You've all just witnessed something absolutely historic and true. Do I see what I want to see? Do I have refolds on the brain? No. Science adds up, to say the least. I've shown so much repetition here. You can take a look at everything on your own time. All the pictures are there. I challenge you to investigate it. I challenge you to investigate it, reinvestigate it, and then re-reinvestigate it. Use the greatest technology to figure these things out. Everything looks simplistic, I have these clay models, but it's really very technical stuff, and it all adds up. Importance of these discoveries: understanding the driving forces of tectonics means understanding better the past, present, and future driving forces of the following: earthquakes and seismicity, climate change, controversial climate change, past and future, resources in the earth, magnetics, possibly, life cycles on Earth, fate of the Earth, fate of the solar system, universe, etc., many, many others. Conclusions. The Earth's oldest rock consists of a coiled chain of Precambrian era refold structures that was inherited from a much larger planet, one that also had plate tectonics and life. Plate tectonics was most likely initiated by a large asteroid that struck North America and caused intense rotation. Plate tectonics on Earth is driven by suction forces created by the movement of the chain of refold structures as a result of distortion and misplacement of the original suture. This model proposes that the Precambrian era rock refold structures determine the character and location of the continents today. The present Earth tectonic model does not have a driving mechanism, as admitted by the geological community. This model introduces a driving mechanism. Understanding the driving forces of plate tectonics helps tremendously in understanding the driving forces of many valuable things that are all undoubtedly related because of fractals, for the past, present, and future. This model should be publicized, studied, and refined by the geologic community and others. Thank you very much to my beautiful wife, kids, parents, rest of my family, my friends, and anyone else that helped me complete this project. I hope you all learned a lot from this, and I hope we pursue this further, and I appreciate you taking the time to watch this. Thank you very much.